I got to tell you about tomorrow real fast. So first thing, we're having a practice day tomorrow. So there is no homework quiz tomorrow. We are going to practice the trig rules. The other thing that I'm going to let you do is if you have your note cards memorized, all right, and you can do this anytime tomorrow. It's open in the morning or after school or during class. But if you can make it through all of your note cards and you have them all memorized, even the new ones that you picked up today, you can have a +5 test pass in the back, the blue ones. All right, you got to have them all though, even the old ones. Make sense? Okay, you don't have to have the stack. You can use my stack, but you have to be able to go through it. All right.
Go up to you and just say all of them.
Yeah, I'll check you during class tomorrow sometime, and we'll do a little practice. And if you don't get it in class and you want to do it after school, you can do it after school. Sound good?
Well, if you can figure out the answer for your homework quiz, then you have. The answer is trial anyways, so.
That's the answer. All right, so that's the game plan for the flashcards. Just trying to get you to start memorizing these guys a little bit. And then you're going to practice all the derivative rules and stuff tomorrow. All right, there are 6 new ones, and they were all on the little note card sheet that you should have picked up and cut out and hole punched into your stack of memorization note cards there. The first 2 is sine and cosine. The derivative of sine is going to be cosine. The derivative of cosine is negative sine. All right. So, if I have this function here, y equals 2 sine x, the 2 is a coefficient, and it's just going to hang out, just like all the coefficients do. They're just connected. What is the derivative of sine? Cosine. So your derivative function is going to be 2 cosine x. All right. On example 2.
Are they just opposite of each other?
So they're split up with the plus sign, but because we have that sum and difference rule, we can differentiate plus and then take the derivative. So I'm going to start with the first term. The 3 is just hanging out. What's the derivative of sine? Cosine. Plus the 4 is hanging out. What's the derivative of cosine? Negative sine. Now what's going to happen when you multiply 4 times negative sine? It just becomes negative 4 sine. So if you want to, which I start having a lot of people skip to this step right here, that is totally fine.
And then you don't even have it. That's just your answer.
Yes, that is the derivative is your answer. All right, on 3, y prime. The 1/2 is going to hang out. What's the derivative of sine? Cosine. And what is the derivative of cosine? Yep, so it's going to be negative sine, so the negative will make that -6 positive. And so you can just write it as +6 sine.
What are the special bases?
Okay, does that make sense so far? All right. So now we get a little pre-cal review here with my logs, because now we're going to talk about logs and e's and ln's. Do you remember what base in ln is? Log base what? E. And what base is a log that doesn't have, like, log x? What would that? Yes.
Cameron.
We did it in pre-cal, and you did in algebra 2. All right, and then there are some certain kind of things about logs and e's that are helpful to know. So ln of 1, which could be on the non-calculator part of your test. What's ln of 1? 0. What is e to the 0? 1. And what is ln of 0?
0.
No.
12.
No.
Log EX. 2.
Danny.
Why does it not exist? The limit does not exist.
You cannot take a log of a negative number or 0. So do you remember logs have that asymptote when you graphed them? It looked kind of like this.
Oh, that's so stupid.
And it has this asymptote right here, 0. So you can't ever go to 0 and you can't go to the negatives. All right, so now let's talk about this guy right here.
It's A.
Yes.
I cancel out.
The E and the L and cancel.
Facts, Judy.
You get A. What about on H? What happens with the L and the E there?
Wait, which one?
H.
Yes.
Cancel.
A cancel and you get A. Okay, and then, refocus. We've got the 3 properties of logs. So I've got ln of A divided by B. If I were to expand this out, yes, you put ln of A and ln of B, and they are going to get subtracted. Because it's dividing. Yeah, it's a lot like your exponent rules. So if you were to expand out 2 things that are being multiplied, what would you put in between them? You would put an addition sign.
What?
Yeah. All right, and then for F, do you remember what happens if you have an exponent? What can we do with the exponent? Multiply, but close. So the N is going to go in the front, and it's going to multiply with the ln of A.
Wait. Oh, is this just from what we learned yesterday?
Flash.
You have those like memorized?
You have to write that on.
That's just stuff you
Sometimes it's helpful, but I'm not super worried about it.
Girl, we don't have a lot.
All right. So let's talk about the other 4 derivative rules that, yes, you do have to have memorized. All right. The first one is the exponentials. The derivative of e to the x is e to the x.
What?
Exact same thing. All right. The derivative of e to the x is e to the x. The derivative of a to the x is going to be a to the x, and then we are going to account for it not being e by timesing by ln of a. All right, so if it's anything besides e, it's going to be itself times ln of whatever that base is. Okay, so exponentials are pretty straightforward. Now, I know the logs, they look complicated, and last year I did not put this stuff on it, and then when we got to some of the more complicated logs, it got worse and no one ever remembered the derivative of logs. So we are going to approach this a little bit differently in just the way that we think about logs when we say the derivative. So what I want you to think of, and this will help later on when we get to more stuff in them, is it's whatever's in the log, the original guy goes on the bottom. So in this case, whatever's in the log, which is x, goes on the bottom, right? The derivative of that goes on top. So what's the derivative of x? 1. So that's why the derivative of ln of x is 1 over x. Derivative over the original.
Okay.
If it is something besides an ln, so a different base than e, it's going to be the same thing. The original on top, on bottom, the derivative on top, but you have to account for the base not being e by putting an ln of a on the bottom with the x. Okay? All right, so now let's practice these guys. And then we'll be done.
Yay.
Yeah. All right. So, example 6. Derivative of ln of x. So the original, whatever's in the log, goes on the bottom.
Every time.
Mm-hmm. The derivative of that goes on top. So what's the derivative of x? 1.
Oh, period. Wait, what'd you say?
Whoa.
Okay, wait, so then for so you use the power
Mm-hmm.
4 of x. And then still 1 of x.
Okay, so let's go to 7 now. All right, the 9 is hanging out. What is in the log? 4x.
So does the 9 hang out?
Mm-hmm. The 9 is hanging out in the front. It's getting multiplied.
Still 1.
Not 1. What's the derivative of 4x?
4.
4.
Wait. I thought it was what? So derivative always
the
means
9
the number without
multiplies.
the.
It's the,
Hold on.
if it's just a plain old x, yes. Like if it was 5x, the derivative would be 5. 7x, the derivative would be 7. But if you're talking about like 2x squared, the derivative would be 4x. Because 2 times
Is
2.
that the power rule?
Yes.
Oh,
Yes.
So it ends up being 9 over x?
I had a misconception of derivative. Continue.
Okay.
The 4's cancel. It's 1 over x.
All right, so the original guy goes on the bottom. The derivative of 4x, which is 4, is going to go on top. The 4's will reduce, and so you can write this as 9 over x. All right, let's keep going.
Actually, we can stop here.
Okay, this is a log rule. What happens with the ln and the e?
Cancel.
They cancel. So I'm not doing the derivative. I'm just simplifying this. And I know the ln and the e are going to cancel.
So it's just 3x plus 7.
So the function is 3x plus
Now we
7.
have to do the derivative.
What would the derivative be? 3.
3, yeah.
Just 3. Because what happens with the 7?
Bye.
It's not relevant. It's 0.
Yes, it's 0 because it's a constant. There's no x with it.
So is that where the power rules apply also?
Yes. So if you have regular terms, like there's no e or ln or trig or just regular stuff with exponents, we power rule all of that. All right, so on number 9. All right, so these are my exponentials. So the derivative of 2 to the x is going to be the exact same thing, 2 to the x, times by ln of 2. Because the base is not e, we're going to account for the base being 2 by timesing by ln of 2.
So then
Plus
3 e to
the x. Yep,
x plus.
that's it.
Oh, you don't have to add anything.
Because it's e.
X.
So the 2 to the x becomes 2 to the x, same thing. Accounting for the base not being e, so timesing by ln of 2. And then the second term, the 3 is hanging out. What is the derivative of e to the x?
0.
E to the x. So it's the same exact thing. And so then this guy right here is my derivative.
Oh, period. I was thinking about how to simplify that, and I was like, I have no idea.
No, yeah. We'll just leave it like that. Okay,
I'm just kidding.
number 10. Shh. Logs. So what is inside this log here? X. And because this is not an ln log, this is a different kind of log, we have to account for the base not being e by multiplying by ln of 4 on the bottom.
Why ln of 4, not ln of 2?
Because the base here is a 4.
Okay. So,
Whatever this base is.
okay, and if it has no base 10?
Yes.
Okay.
All right, now what is the derivative of x?
1.
1.
And then we write another equation for the other one.
So the 4 is hanging out. What is inside this log?
Just the underside
X.
1.
And then the derivative of x, which is 1. So you could, if you wanted to, you could rewrite this as 1 over x ln of 4 minus and then 4 over x. Because you could put that 4 on top. Which is probably the more common way that you would see it.
And is that the answer?
Mm-hmm. Okay, let's go to 11. Okay, so on 11, this ln of x squared, you could do this 2 ways. So first, let's just use the derivative rule. So what is inside the log?
Squared.
X squared. All right, the x squared is in the log. What is the derivative of x squared?
2.
2x.
So is that the power rule right there that we just did?
Yep.
Oh, let us simplify.
So x squared, the 2 goes in the front, minus 1 from the exponent, which would be an understood 1.
So then it just becomes 2 over x.
Okay, I'll get there in a second. And then plus, what's the derivative of sine? Cosine. And so then, like you're saying, that reduces to just 2 over x because you have an x on top and x2 on bottom. So you can take 1 away. You can reduce 1. And so you're left with this.
Thank God, that's the answer.
Now, another way you could think about this is using your log rules. I can move that 2 in the front and rewrite that as 2 ln of x, right, because it's an exponent, which would be 2 times 1 over x, which you get the same thing. But if you don't know your log rules, it's okay as long as you know your derivative rule. Is that okay?
Yep.
Okay. All right, next one, number 12. So what's the derivative of 2 sine x? 2 cosine x. Plus, what's the derivative of 5e to the x?
Just be 5e to the x.
5e to the x.
That's the answer.
Yep. Okay. 13, what's the derivative of 3 to the x?
3 to the x times ln of 3.
ln of 3. Because the base is not e, we have to account for that. But you'll first write the exact same thing, account for the base not being e, and then the derivative of negative 4 cosine x
4 sine.
Plus 4 sine.
plus 4 sine x.
Why is it plus now?
'Cause the
you can
negative they both made it positive.
Okay.
So the derivative of cosine is negative sine, so double negative. Okay, 14, the derivative of log base 4 of x. So whatever's in the log goes on the bottom. We're going to account for the base not being e by timesing by ln of 4 on the bottom. And what is the derivative of x? 1
Minus cosine x.
minus cosine x. And then I think, is this my last one? Or the last one on this? I think there's 2 more on the next page.
Really, I didn't think so.
All right, so the next 2 are I'm plugging in numbers. That's the only difference.
Oh shoot, so it gets harder.
No, you just plug it in.
All right, let's do this one. So 15, we're going to first take the derivative. So what's inside the log?
X minus 7 to the x.
X.
Oh,
X.
it's just x?
Just the x is in the log. So x is going to go on bottom. What else is going to go on bottom?
ln of 8.
ln of 8. And what's going to be on top? 1 minus, what's the derivative of 7 to the x?
Just
7x, and then you have to account for the ln.
So ln is 7. All right, so a lot of memorizing.
Yeah, that's unfortunate.
So you just got to know the rules. If you know them, they're not hard to use. You have to know them. All right, so the last 2 that I have here is finding the value of the derivative at a given point. So first we're going to take the derivative, and then we'll plug in our x value. All right, so f prime of x, what's the derivative of 3 ln of x? The 3's hanging out. Times. What's in the ln? X, and what's the derivative of that? 1. Plus, and then what's the derivative of e to the x? E to the x. So now that we have our derivative, what are we going to plug in for all my x's? 5. So I have 3 times 1/5 plus e to the 5th, which really you can just write that as 3/5 plus e to the 5. And if you didn't have a calculator, you couldn't go any farther. Okay. And then my last one, which is trig. So first I'm going to take the derivative. What is the derivative of 3 cosine x?
Negative 3 sine x.
Negative 3 sine x. All right, now with the sign. This 2 here is a coefficient. It's like saying 1/2 sine x. Does that make sense? All right, so the 1/2 is just hanging out.
1/2 cosine.
Yes.
You put higher.
All right, so the 1/2 is hanging out. The derivative of sine is going to be cosine. So this is my derivative. And then now I'm going to plug pi in. So f prime of pi, so negative 3 sine of pi plus 1/2 cosine of pi. And then some people are asking, like, do I have to simplify that? And it's not a great answer. It's a gray area. Sometimes yes, sometimes no. I don't know when. I even asked this when I took like a APSI class, and they were like, oh, sometimes matters. So if you know how to simplify the trig, go ahead and simplify. If you don't remember, you're like, I know I'm going to get it wrong if I simplify this, just leave it like that. You might lose a point, but it's better than losing. Yeah. So, but hopefully you know how to simplify where pi is. I would hope that you would know that one. So pi is right here at -1, 0. So the sine value is going to be what? 0. And then the cosine value is going to be -1. So -3 times 0 is going to be 0 minus 1/2, which is -1/2. All right. Sweet.